Okay, quick review. We left off, we're dealing with piecewise functions. Okay, and remember that's it's one function, in this case g of x, that has different functions for different parts of the domain. And it's up to you to kind of analyze and see what you can come up with. But notice for this we had from -8 to -4 in my domain, I had a parabola, which is a frown. And notice we know that's going to be a negative x squared. And we notice we do some problem solving where we're like, here's where our vertex is instead of the origin. But I notice if I go 2 to the right, 2 squared should be 4 or a -4. Instead, we only come down 2. So instead of being 4, it was 2. So we figured out that's 1/2 x squared. Okay, and a negative because we're going down. Okay. The rest of these from -4 to -2 was a line with up 1 over 1, slope of 1, up 1 over 1, and it would have had a y-intercept of 4. So that's 1x plus 4, x plus 4 from where? -2 to 2. I'm sorry, from -4 to -2. Okay? And then here you can do an absolute value or just a line and another line, which is what I actually did. I've got a slope of what? Down 2 over 1, down 2 over 1. So my slope is -2. Y-intercept is 1. So from -2 to 0, I have a slope, I have equation of -2x plus 1. And here I have from 0 to 2, I have a slope of up 2 over 1. And that's going to be 2x with a y-intercept of plus 1. Okay? And this was they told you this is a cosine or sine function. It's a sinusoidal graph, and this ends up being, if I come from here to here, it comes all the way down to 0. From 3 to 2, it goes all the way down to the bottom. They said this is a max and min. So every unit, it comes back up and hits 0 and comes back up. So we figured out this was cosine peaks on the y-axis. Sine is 0 on the y-axis. So this is cosine. But notice the amplitude is 1, 2, 3, so we realized that was 3 cosine of, we plug in pi halves x, because you notice 1, 2, 3, we also use different numbering systems as if it was just a trigonomic function. So 1 would be 1, if I plug in 1, that's 1 pi half, cosine of pi halves is 0, I plug in 2, 2 over 2 is 1, and that's cosine of pi is, notice, -1. And you get over here all the way up to, let's see, 1, 2, 3, this is 4, I'm sorry, I didn't have to, this is 5. Cosine of 4 over 2 is 2. What's cosine of 2 pi? That's all the way, is 1, and 3 times 1 is up here. So there's your cosine graph. And that's kind of a piecewise function. This is more of parabolic again. And this is going to be, my vertex is right here. I go over 1. 1 squared should be 1. Instead it's 2. That would be 2x squared, and it's a smile. So different functions for different domains. Okay? All right. Let's review some of the things we'll be doing. Here's some graph. I've got inflection points where concavity changes. This is not an inflection point, no concavity. But here's a smile. Here's where we go to a frown. There's an inflection point. Frown to frown, concavity, and here's an inflection point. Now it's concavity switches to a smile. And right here, it looks like I kind of switched up. This should be an inflection point about here, where I go from a smile to a frown. So inflection point, inflection point, inflection point. I've got relative maxes at here and here, and an absolute max here. I've got a relative min and an absolute min here. I've got a relative min here as well. This is also the relative and absolute min. Remember, for relative or max or min, you need to have a change in slope, down, up, or up, down. Okay? Concavity we talked about, and inflection points. All right. Now let's talk about some transformations. This graph is f of x. Okay? Let's say, all right, here's my graph of f of x. Okay? So what would the graph of negative f of xb. So g of x is negative f of x. So what's this negative do? This is outside the function, so remember our acronym, HIVO, which I had written up here, I forgot to show you. Remember, anything that's outside the function is vertical. So basically, this is affecting anything outside is vertical. It affects my output. So basically, I plug in a number, I apply the function, and then my y value, I change the y value. So this basically, when you change y values, like so, this is now, everything's going to flip and reflect across the x-axis, okay? So notice how this graph now is going to look like this, okay? So I basically took this graph here, and notice this is going to be down here, this is going to be up here, this peak is down here, okay? So that's what g of x equals the negative of f of x, okay? So if I want to find g of 3, okay, I go find f of 3, and let's say that's f of 3, and then I apply a negative, and it'd be whatever that value is. Here's g of 3, let's say whatever that value is, I just change that value to, change the sign, so it'd be down here, okay? G of negative 4 would be the opposite, again, of f of negative 4. So I come here at negative 4, let's say this is negative 4. Let's say that's, okay? And then we're going to flip it, and it's going to be this value. So whatever this y value is, you just change the sign so it's down here, okay? All right? Let's look at now f of negative x where it's inside the parentheses. Horizontal input, HIVO. We're affecting, this is going to be a vertical component, flipping my hand here, flipping. Okay, I'm affecting the input. So now, when I come in with, let's say, a 1, before I plug in 1 to my function, I change the sign and make it negative 1. So I come in with 1, make it a negative, and I apply the function. So I'm really getting the value of this over here now. It flips over here. Okay, if I come in with negative 1, before I plug in negative 1 into the function, I change the sign so it's the opposite of negative 1. So I'm plugging in 1. So when I come in negative 1, I'm actually getting the value of 1 comes over here. Okay, so things flip-flop across. So this would give me a reflection across the y-axis. Things flip across the y-axis, okay? It's reflection. They're just going to flip, okay? Like I said, if you come here with 1, before you plug in 1, you're going to change the sign, and it's going to be negative 1. So you'll get the value that was over negative 1 is now going to be over here. If I come with negative 1, what's the opposite of negative 1 is positive 1. So the value of 1 comes over here. So this type is horizontal flipping. It's reflection across. This graph will reflect across the y-axis. Okay, the whole graph just flips across the y-axis. Where before, this one here, it flips, the whole graph flips across the x-axis. Okay? All right, changing the output, changing the input. All right, now, I'm up to 8.5 minutes. Here is where g of x equals f of 2 of x. Notice my 2, I'm changing f of x, I'm changing this 2 is in the parentheses, okay? So it's horizontal, HIVO, horizontal. Okay, it's not really stretching more than it is, it's a compression, okay? So what happens would be, I come in here at 1, okay? But before I run the function, I get, let's say I come here at 1, but before I plug it in the function, I multiply it by 2, so then I plug in 2 times 1, which is 2, and I get the value that usually is over 2, it moves over here, okay? And by the same token, if I came in at negative 1, normally it'd be negative 1 down here with this line, but instead, what's 2 times negative 1? Before I plug in negative 1 into our function machine, I multiply it by 2 and I get negative 2, and the value of negative 2 comes over here. And you notice how things get squeezed in. That's a horizontal compression, okay? Things are going to get, all these values, you get values associated with bigger numbers or more negative numbers come in. You come in here and you get the value of 2. If I come in here, I get the value of negative 2. And things get squeezed in. It's a horizontal compression. if that was a fraction, 1/2, if I came in at 1, or let's say I came in at 2, I would get the value of, if this was 1/2 x, here it would flatten out. We're going to be horizontal stretching along this x-axis. Things come apart. Because if I came here at 2, before I plug in 2, I times it by 1/2 and get 1, and I get 1's value. And notice how things get pulled apart. Okay? That's a horizontal compression, and if it's a fraction, less than 1, it's a horizontal stretch. That's different than the vertical outside. That's a vertical stretching, and notice that in here, at no time did I ever pull values up and to affect amplitude. I just move values inside, or in this case, pull values outside. Here, I'm affecting the amplitude. You come in with some function, f of x, and then if I take that and double it, now all of a sudden, all these values get doubled, and it's up here now, okay? So that's how you affect outside. It's a vertical stretch, or if it's like 1/2, it'd be down here, okay? So outside the function would be vertical stretching or compression based on greater than 1 or fraction. Inside is considered horizontal stretching. That's when you get the fraction. When things you come here with 2, you multiply 1/2. I get values from here come out. So if it's greater than 1, it's compressed. Things are getting compressed. It looks like kind of like it's stretching, but it's not. The amplitude's not affected. All right, 11 minutes. I got to crank it out. Here's absolute value. So the whole function is inside the absolute value. So notice, if this is f of x, what's going to happen is, if I apply g of x, where this whole value gets stuck in an absolute value, I will have no more negative values. This right here would come on up. This right here is going to move up here, as is this right here. So anything down below is now up here, and here's my graph. Because this absolute value prohibits all my outputs from being negative. I can still have negative inputs, okay? But all my outputs are now always positive, okay? That's going to differ from this right here, where now this graph of f of x, notice if this is f of x, a normal f of x graph, okay? Here's my graph. Well, now I'm going to change g of x equals f of the absolute value of x. So notice what happens. I no longer have any negative inputs. I will no longer have this graph because I don't have any negative inputs. So here is what this graph is going to look like. It's basically, I'll come in with negative numbers, but I do what? I make the absolute value of them first. So I get always the same value as that I would over here as for positive. So notice this whole graph just reflects over. This graph is gone. And x of 1, 2, 3, 4 is the same of negative 1, 2, 3, 4, because these are all going to be absolute values. So negative 1's 1, negative 2's 2, and I get the same graph here as I have over here. Okay? And I want you to think about that, okay? All right? And finally, real quick, we've kind of talked about, if g of x is the function of f of x minus 4, this is just a whole graph that is going to move down, or if it was plus, it would move up. The whole graph, this is the whole graph after, this is moving all my outputs down minus 4, or let's say plus 4 in this case. You go down or up, okay? And finally, inside the parentheses is a horizontal, okay? A horizontal shift. All right, notice, if I come in at 0, I normally get 1. But before I plug in 0, what do? I normally, like I said, f of x, this is f of x right here, let's say. Okay? But g of x equals f of x plus 2. It's inside the parentheses. This is plus. It's a horizontal shift to the left. This whole graph is going to go over 2. Okay? Here's why. If I plug in a 0 here, I come in here at 0, but instead of doing the function at 0, I add 2 and I take the function of 2. Well, what's my value of the function of 2 here? This moves over 2 to over the 0 position. Okay? So notice how this graph plus comes left, minus this whole graph would go right to. It's horizontal inside. Okay? Like I said, if I wanted to evaluate g at 0, I plug in f 0 plus 2, because that's what g of x is f of x plus 2. And I'd get my value of what, f of 2, and that comes over because here's my input at 2. I came in at 0, but I'm getting the value of what? 2, and that's for g of x, g of 0. Okay? All right, 15 and a half minutes, that's enough. All right, see you tomorrow, guys.